Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aina Akila binti Bahanuddin. My metric number is B122310085. Today we are going to present to you the assignment Understanding RF Communication in Television System. Radio frequency or RF communication is a way of sending information wirelessly using electromagnetic wave. It operates in the frequency range from about 20 kHz to 300 GHz and is widely used in technologies like radio, television, mobile phone, and Wi-Fi. Information like voice or video cannot be sent directly, so it is added to a high frequency signal using modulation, and this helps the signal travel far. And RF communication allow wireless communication and lets one transmitter send signal to many receivers at the same time.
Hi, my name is Nura Aina Izzati binti Rosli. My matrix number is B122310189. Now, I will explain the complete block diagram of an analog television transmitter. The system is responsible for transmitting both video and audio signals from the broadcasting station to television receivers. The transmitter consists of several stages, starting from signal generation, modulation, amplification, and finally transmission through an antenna. The transmission section of the broadcast unit has two main parts. The first part handles video transmission using amplitude modulation, and the second part handles audio transmission using frequency modulation. These two signals are processed separately and then combined before being transmitted. Next, I will explain about the television receiver process. The television receiver performs a reverse function of the transmitter. It must capture a weak radio frequency signal from the air, extract the audio and video information, and convert it into something we can see or hear. This process involves several key stages, from tuning and amplification to the modulation and display. So I'll pass to the next person to explain about the simulation.
Assalamualaikum, my name is Nur Afifah Alia. Moving on to the next simulation result. In this part, we are verify the theoretical design of our RF communication system using multi-SIM. Starting with the RF oscillator stage, we used a Colpit oscillator, which is a common choice for RF circuits because it's simple and stable. To calculate the resonant frequency, we first find the equivalent capacitance of the capacitive voltage divider, which is 23.5 nanofarad. Then using the inductor L1 equal to 10 mH, the resonant frequency FR here, we get the value around 10.38 kHz. When we run the simulation, the measured carrier frequency fluctuates slightly around 1 kHz. Here is the waveform generated by the RF oscillator. As we can see, it's clean sinusoidal signal, which is essential because the stability and consistency of the carrier directly affect the effectiveness of modulation and the quality of transmission. This carrier will now be ejected into the next stage, which is the modulator, to encode our information signal. My friend will continue explain that part.
Assalamualaikum, my name is Nur Akila binti Aminullah and my matrix number is B122310215. So today I will explain about simulation result. So I will explain about the result, which is for modulator. The first one is purple waveform, channel A. The purple signal shows a stable sinusoidal carrier signal generated by the oscillator. And then red waveform, channel B, indicates the modulation signal with sharp transition for accurate control. And lastly is green waveform, channel C, shows the resulting AM signal, confirming successful modulation as the carrier amplitude varies according to the message signal. Okay, and then I will explain about the simulation result for the modulator. So the first one is purple, red, green waveform, channel A, B, and C, represent the original message, carrier or modulated signals from previous stages. And then lastly is blue waveform, which is channel D, represent the demodulated output, appearing only at this stage as a slow signal. This recovered waveform closely resembles the original input signal, audio or test sinusoidal signal applied at the transmitter.